G'day everybody. In our lesson today we're going to start looking at the fundamentals of probability. In particular we're going to do a lot of work with Carnot tables. How do we organise information in Carnot tables? How do we use those tables and probability tables to calculate probabilities? We'll come across a couple of formulas or rules in this lesson. One is what we call the addition rule for probability, and we'll also do some work calculating conditional probabilities. A lot of our work in this lesson is going to focus on this situation. Out of 150 students in Year 7, 75 have visited Melbourne, 45 have visited Sydney, 45 students have been to neither of these places. So we've got some information here that is maybe not complete, and we've got a bunch of students. Some have been to one place, some have been to another place, maybe some have been to both, some have been to neither. One way that we can start to organise this information is to use a Carnot table or a Carnot map. It's easy to draw up, so this is what a Carnot map would look like initially. And you can see here we're starting to organise the information with some labels. So I have some students who have been to Melbourne, so I'm going to use a capital M to signify Melbourne. And capital M with a dash is what we call the complement. So students who have not been to Melbourne. And they are complementary because it sort of covers all of the students. If I look at all of the students, I can put them into categories based on whether they've been to Melbourne or whether they've not been to Melbourne, and there's no overlap of those two sets. Likewise, we have students who have been to Sydney and students who have not been to Sydney, and we can see how these overlap, or what we say intersect, with each other, all of these sets of students. Straight out of the information given, I've started to put some information into the map. We have here 150 students in total. We know that 75 have visited Melbourne, and this is going to eventually constitute some students who have also been to Sydney, but some students who have been to Melbourne and not to Sydney. We're told that 45 students have been to Sydney, and we're also told that 45 students, this 45 here, have not been to Sydney, neither have they been to Melbourne. So neither of those places. So we've got an intersection there. And what we're left with is a bunch of other cells that are currently empty that we can now solve. So all of these rows and columns will add up. So these two values here should give us a total of 75 students who have been to Melbourne. These two cells here should give us a total of 45 students who have been to Sydney, and so on. So let's have a look at how that works. Just by way of notation, you can see here I've solved the fact that 105 students have not been to Sydney, and I knew this because 45 have been to Sydney and there's 150 students altogether. So this is an example of what we call a complement. This 45 plus this 105 must go together to give us what we call the sample space. And that's a representation of that fact in this equation here. Likewise, if I've got 75 students who have been to Melbourne, I must have 75 students to make up the 150 who have not been to Melbourne. Once I've worked out those two pieces of information, because I know that 105 students have not been to Sydney and 45 have not been to Melbourne, of those students, I can say that 60 plus 45 is equal to 105. That tells me that of the 105 students who have not been to Sydney, 60 of them have been to Melbourne. So we've got this intersection here. So these two cells add up. Likewise, I can work out that this cell is going to be 30, and we've got one more cell remaining. And whichever way we look at it, whether we look at it as 15 plus 60 equals 75, or 15 plus 30 is equal to 45, I know that this cell must be 15. So that completes the Kano map. We've got all of those cells filled in, and there's a lot of information there that we can see all at once. We can see the sample space. So using that epsilon, the number of students in the sample space is 150. For example, we know that the number of students who have been to Melbourne is 75. And here we have an intersection of two sets of students. So the number of students who have been to Melbourne and not been to Sydney must be 60. So that's just 3 examples of what we can read from a Kano map. We're going to begin to use this Kano map to calculate a few different probabilities. So based on this information, we're going to start with finding the probability that a randomly selected student has been to Sydney. Just the general formula for the probability of an event is the number of ways that event can happen over the total number of things that can happen. So the probability that a student has been to Sydney would be the number of students who have been to Sydney divided by the number of students in the sample space. We get both of those pieces of information from the Kano table. Students who have been to Sydney is 45, the sample space is 150, so 45 out of 150 students means that a randomly selected student, the probability that they've been to Sydney must be exactly 3/10. Find the probability that a randomly selected student has been to both cities. So this is what we call an intersection, and you can see the upside down U signifies that we are looking at an intersection. Students who have been to Melbourne and been to Sydney. So the intersection of those two sets of students divided by the number in the sample space, and we can see there are 15 in the intersection. 15 students who have been to both places out of 150 means that the probability is 1/10. Find the probability that a randomly selected student has been to at least one city. We're actually going to look at this problem twice. There's 2 ways we could calculate it. It's what we call a union. So this involves a set of students that includes students who have been to one of the cities, but possibly both as well. So we are looking at these 3 cells here. So 15 have been to both, 30 have been to Sydney but not Melbourne, and 60 have been to Melbourne but not Sydney. So of those 3 sets of students, they represent all of the students who have been to at least one city. In other words, they represent the union of those 2 sets. That gives us a total of 105 out of 150, which simplifies to 7/10. The second way of calculating this is to think about the complement. If a student has been to at least one city, the complement of that would be the set of students who have been to neither city. And so we've got an intersection, students who have not been to Melbourne as well as not having been to Sydney. That's going to be 105, so we've got 150 students minus the students who have not been to either city is 105, and we get the same result as before. That simplifies to 7/10. So that's an alternative way of working with the union of the 2 sets. Just to show you that the wording of these questions makes a lot of difference. Find the probability that a student has been to only one city. We've got a combination of 2 intersections, students who have been to Melbourne and not Sydney, students who have been to Sydney but not Melbourne. So we're looking at the 30 students and the 60 students out of the whole sample space, gives us 3/5. This is where we start to working with conditional probability. We're now being given a bit of extra information about the randomly selected student. They're not purely random. We've been given some information that this randomly selected student has been to Sydney, and we're looking for the probability that they've been to Melbourne. So the way in which we say that the probability that a randomly selected student has been to Melbourne, given that they've been to Sydney. Conditional probability. It's another way of describing this is a reduced sample space. So we're not talking about the entire sample space anymore. It's not out of the 150 students. It's only out of the number of students who have been to Sydney. So in the diagram now, we're sort of no longer interested in this side of the Kano map. We're purely interested in these values here, the students who have been to Sydney. The probability that one of those has been to Melbourne would be 15 out of 45, which is exactly 1/3. We're now going to look at how we transfer that information to a probability table. To create a probability table, we're going to end up with probabilities, obviously, but we're going to use the sample space. Each of these values divided by 150 will give us the probabilities in that table. So you can see we organise it in a very similar way to a Kano map, but our probability, total probability, is going to be 1. And dividing each of those values in the Kano map by 150 and simplifying those fractions, these are the separate probabilities that we can talk about or use. So just a few questions we'll revisit. Find the probability that a randomly selected student has been to Sydney given that they've been to Melbourne. Instead of talking about numbers here, we're talking about probabilities. And you can see that we're going to use 1/10 as the probability that a student has been to Sydney out of the students who have been to Melbourne, and the probability that they've been to Melbourne is 1/2. And so the conditional probability is 1/5. Find the probability that a randomly selected student has been to at least one city. So this was about the union. Here we're using the rule that if we're interested in the probability of the union, we're going to add the probability that they've been to Melbourne, added to the probability that they've been to Sydney. So these two probabilities here. But in doing that, we have to recognise that there are some students who have been to both places. So we've sort of counted this probability twice. And so we need to subtract that. So minus the probability of the intersection. And so we get the probability of 1/2 plus 3/10, subtract the intersection, which is 1/10, means that we've got a probability of 7/10. And of course, we can also use the complement of the intersection. So the complement of the idea that they've been to neither city. In this case, we're just going to subtract that value from 1, and that will also give us the probability of the union. Probability that a student has been to at least one of those cities. What we're looking at here is just a quick summary of things that I've discussed in this video. Right at the end there, we talked about the addition rule. It's an equation with 4 terms, so we can always solve one of those terms if we know the other 3. We've looked at 2 ways of calculating the probability of the union using this equation and this equation, and we've also covered very quickly the formula for conditional probability. So talking about Kano tables, we've introduced a lot of terms in this lesson. We've used those tables to make probability tables, calculating probabilities in different ways, and looking at the addition rule and conditional probabilities. As usual, if there's things that have confused you, write those down. We'll look at those in class and complete the Google form to log your attendance and to check your understanding. Thanks very much.